So constant, slope, decrease, exponentially, increase, and rest. Okay, we're on slide 18 for our notes. Okay, now, very quickly, blue, right here, blue is our displacement graph. Green is our velocity graph, and orange is our acceleration graph. The reason I color coordinated is just so we can keep ourselves organized and we can keep our work clean, and I can differentiate between all three of these graphs, okay? Very quickly, displacement. Let's start with a quick example. Displacement. Look at displacement. The reason I know this is a displacement graph is because it has the d of t and t on the x-axis. X-axis has time, and y-axis has d, which is displacement. Now, when I see a displacement graph with a flat surface like this, that means it's flat. That means I'm not moving. I'm not changing direction. I'm not moving my position. My position is the same. So if my position is the same, that means my object is at rest. That means I am not moving at all. I am not moving a single muscle, okay? So my object right here is at rest, okay? Now, if my object is at rest, if I have zero displacement, that means both my velocity and my acceleration are going to be zero, okay? Both my velocity and my acceleration are going to be zero because velocity is affected by displacement. So velocity is a change in displacement, and acceleration is a change in velocity. So they're codependent on each other. So if the displacement is zero, if it's not moving, that means I'm not going anywhere, and that means I'm not speeding up or slowing down. So velocity and acceleration is zero, okay? Let's go on to the next one real quick. Let's go with walking. What happens if I walk? Let's say I walk forward, okay? Let's say Mr. Castillo is walking forward, okay? So as you see the graph, the displacement graph, it is going up. The slope is a positive slope. Oh, it's a positive slope. So that means I'm actually changing my position. My position, my original position, and my final position are different. So I'm walking away from my original position. So I'm finally moving, right? If I'm finally moving, that means I have a constant velocity. That means my velocity is flat. It's a flat surface. That means I am not going fast. I'm not going slow. I'm not slowing down. I'm just walking. I'm chill. It's like he's just chill. He's just walking down the park. So I have a constant velocity. Now, if I have a constant velocity, if my velocity is not changing, that means I have 0 meters per second for acceleration. If my velocity is not changing, which is not, because if it's constant, my velocity is not changing, that means my acceleration is 0. Remember, acceleration is the change in velocity. If my velocity is not changing, that means my acceleration is not changing, okay? Let's go with the next one real quick. What happens if I'm increasing? What happens if I am exponentially increasing? That means I am running away. What happens, let's say, for example, Mr. Castillo sees a spider. I see a spider, and I get very scared. So I start running away. I run super fast. I run so fast that I am increasing my distance over time, my displacement over time. So you can see my velocity is increasing because if I'm running really fast as the time progresses, that means my velocity is increasing. That means I'm trying to get the heck out of there. Mr. Castillo is trying to run away. Now, if my velocity is increasing, that means my acceleration is constant. Because what do we learn about acceleration? Acceleration is the change in velocity over time. So if my velocity is changing, that means my acceleration is constant, okay? It means my acceleration is constant, okay? Now, let's go with two more. Oh, there you go. There's two more. Walking. What happens if I walk back? Okay, what happens, for example, let's say Mr. Castillo, he doesn't see the spider anymore. The spider is gone. If the spider is gone, I'm gonna walk back. Like, no cap, I'm about to walk back. So Mr. Castillo is walking back to his original position. So I'm walking backwards. Look at that. I'm walking back until I get back to my original position. That means if I'm walking back, I'm really chill. I'm not running. I'm not slowing down. I'm just walking back. That means my velocity is also constant. But instead of a positive velocity, it's going to be a negative velocity. You see my graph right here? Do you see how on this one, my velocity was up above the graph, above the x-axis? And this one, my velocity is below the x-axis. That means I am a negative number. So if I'm walking back, my velocity is negative, because remember, negative means that is a vector, right? Velocity is a vector. So if it's a negative number, that means my velocity, I'm coming back. I am running back. I am walking back, okay? And my acceleration is 0. Because if my velocity, like I said, if my velocity is constant, that means that I'm not accelerating or decelerating. So my acceleration is 0. Now, for this last part, I'm going to put a square right here because I did not like this graph. And so I'm just going to put an X right here. So you put an X as well. We're not going to worry about that. It just looks, I made a mistake. So we're not going to do that. Okay. X right there. Let's focus on the last part. Okay. Let's focus on the last part. So what happens if my velocity is decreasing? What happens if my velocity is decreasing? That means I am now going backwards. I am slowing down at a constant pace. So if my velocity is decreasing over time, I am slowing down. That means my acceleration is decelerating. Okay? So if my velocity is negative, if my velocity is decreasing, that means my acceleration is going to be decelerating. It's going to be negative. So I am decelerating. I am decelerating. Because what happens when you're driving? What happens when you're driving and all of a sudden you have to make a stop? You slow down, right? So your velocity goes down, which means your acceleration is decreasing. Okay? Decreasing.
Okay, this is what we're doing right now. So we're going to watch a video. One of my favorite clips from the Avengers Age of Ultron movie. I personally love Age of Ultron. I feel like it's such an underrated Avengers movie. I'm willing to debate, though we can talk about that some other time. But we're going to watch a video real quick, okay? So let's watch this video real quick. So we saw the video. I want you to record the time it took for each of these events, okay? For each of these events. So when Black Widow hits the road, that's all 0 seconds. She just started, right? What happens when she grabs Captain America's shield? Well, I'm going to give you a hint. It takes about 11 seconds for her to grab Captain America's shield, right? Okay? And I want you to give me how long it took between each of these events. So how long did it take? Okay? How long did it take? Okay? I'll give you a hint. It stops at 73 seconds. When she says beep, beep, it's the 73-second mark, okay? And I'll give you one more. When Black Widow stops, it's at 41 seconds when she stops. Okay, so here are our values at each of these time frames, right? At each of these time frames, okay? Now, let's look at this real quick. Let's actually record some data. So you're scientists, you're recording some data. We know when Black Widow hits the road, everything is 0, right? Everything is 0 because nothing's happening. No one's moving, right? Like she literally just started. So acceleration, time, velocity, displacement, distance, everything is 0, okay? So when Captain America grabs his shield, how do we know how much distance when Black Widow grabbed Captain America's shield, how much distance did she travel? Well, we know that she traveled 20 meters per second, right? How many meters she traveled in 11 seconds? So if she traveled 20 meters in 1 second, how much meters did she travel in 11 seconds? So Lourdes, you multiply 20 by 11. Okay, awesome, awesome. Yes, if she traveled 20 meters per second, and you multiply that times 11, you will get 220 meters. So that's how much she traveled in that small time frame. She traveled 220 meters if she was traveling 20 meters per second in 11 seconds, okay? All you gotta do is just multiply it. It's just a simple math, multiply, okay? Good job with this. Okay. Now let's look at the next one. Let's look at acceleration. I know acceleration is my final velocity minus my initial velocity divided by my final time minus my initial time. Okay? So very quickly, if I'm focusing on this part right here, when she grabs Captain America's shield, what was her final velocity when she grabbed Captain America's shield? So when Black Widow grabbed Captain America's shield, what was her final velocity? At what velocity speed was she traveling? So once again, the final velocity was 20 meters per second because when she grabbed Captain America's shield, that was her final velocity. So what was her initial velocity? What was the velocity she started off with? It's 0, everyone. Her initial velocity was 0. She started at 0. She ended at 20 meters per second. How about for my time? What was my final time? Yes, 11. It took her 11 seconds to do that. So what was her initial time? Her initial time was 0. Are you guys seeing the little trend? Are you guys seeing the little pattern here? Hopefully you guys seeing the little pattern. So final velocity minus the initial velocity, which was the previous one. Final time minus the initial time, which was the previous one. So can anyone tell me what acceleration was here? What was her acceleration? 20 minus 0 is 20. 11 minus 0 is 11. So what's 20 divided by 11? Divided by 11 is 1.81 watts. Be specific on my units, please. Thank you, Emily. Meters per second per second. That means, which makes sense because that means when she grabbed Captain America's shield, she sped up. She accelerated, right? She accelerated. Okay? Okay? Let's do one more. How about here? Let's do this right here. When Hawkeye says now, she was traveling 15 meters, right? 15 meters. And she did this in 17 and at the 17-second mark. However, what was the difference between the 11 seconds and 17 seconds? So how long did it take for Hawkeye to say now? So even though it was at the 17-minute mark, it took him 6 seconds. It took him 6 seconds to do that. Okay? So between Black Widow grabbing Captain America's shield at 11 seconds and 17 seconds when Hawkeye says now, we know that Black Widow was traveling 15 meters per second. So we know that she was traveling 15 meters per second. Right? And she did this in how many seconds? She did this in 6 seconds. Okay. So what's 15 times 6? Wait, where are we getting 6 from? Oh, so we can multiply 15 times 17. You know how we multiply 20 times 11? We can multiply 15 times 17 because 17 is the whole entire time she was driving. So we know that in 11 seconds, she traveled 20 meters per second. At the 17-second mark, she traveled 15 meters per second. So that means there's a 6-second time frame. 17 minus 11 is 6 seconds. So in 6 seconds, she traveled 15 meters per second. Yeah, so we subtracted. We subtracted 17 minus 11 to get 6 seconds. So what's 15 times 6? How much did she travel? She traveled how much? 90, yes, 90 meters. She traveled 90 meters, right? She traveled 90 meters. Now, is that the total distance she traveled? Did she really travel 90 meters from beginning to end? Thank you for my units. Did she travel 90 meters from beginning to end? Or how many total distances did she travel? Total? she traveled 220 meters plus 90 meters. So all you're doing are just adding these two together, adding the previous one to the current one. So what's 220 plus 90? There you go, 310 meters. So she really traveled, at this point, she is traveling about 310 meters at this point. From beginning to end, she has traveled 310 meters when by the time Hawkeye says now, okay? By the time Hawkeye says now. So I hope you see the pattern. You're adding the distance because distance is the total length traveled, right? So you're adding the distance every time you get a new number. You're adding them all the way till you get to 2,478. That's how much distance she traveled from beginning to end. So it has to add up to around 2,478. And to find the acceleration here, all you gotta do is take the final velocity, which is 15, minus the initial velocity at this point, which is 20, divided by the final time, which in this case, it was 17 seconds, minus 11 seconds, which was what? It was actually 6 seconds. Okay, so what's 15 minus 20 divided by 6? What's 15 minus 20 divided by 6? It is negative 0.833 meters per second per second. That means she decelerated. She decreased her velocity. So she decelerated. You see that? She decelerated. That means she slowed down, which makes sense because when Hawkeye says now, she makes that turn, right? He's like, now. And look, she made that turn. So when you make that turn, you actually decelerate. Will it always be negative 20? It will always be minus. You always take the final minus the initial in this case. So you're always going to do it the two previous values. So for this one, you're going to use 12 and 15. And you're going to use 33 minus 17, which is different time. For this one right here, you're going to use 5 and 12. So you keep stacking on them each other. You keep stacking and adding to them, okay? Now, I know this may have a little bit confusing, so don't fret. If you go to your physics classroom tab, if you go to resources, to week 2, if you go to week 2, there's an Ed puzzle right here that actually explains everything into more detail. So if you're confused, watch this Ed puzzle video. It's not mandatory, but it can help you out. And if you still have questions after that, just come to my office hours on Thursdays, 9 a.m. to 12 p.m., and I can help you out, okay? So watch the Ed puzzle if you're still confused, or come to my office hours on Thursdays.